emergency? What's the location of your emergency?
But it's in the warehouse space behind 7670 Hooper Road, the west end of the building. It's completely on fire, popping, cracking.
And you see flames?
Flames, it's popping and cracking, like we can hear it.
Do you know what's in those warehouses?
Should be no chemicals or anything like that. Oh my. My boyfriend just said it looked like the AC unit back there looked like it exploded. The whole shop is on fire.
And you don't know if anybody's inside there at all, do you?
We have no idea if anybody's inside there.
Okay.
But the fire's getting pretty big.
Okay, PBSO, you're en route, correct?
Yes.
This fire that occurred on October 17, 2021 at 2:32 a.m. should change how firefighters and incident commanders formulate their fire attack before making entry. From the exterior, it looks like a typical mechanics bay, as all the other shops that neighbor the building. But the difference is, this specific bay was retrofitted without permits. And this increased the fire load, resulting in higher burning temperatures, leading to a potential serious incident, a mere 24 minutes after the initial 911 call was received.
Battalion 3-4 responding.
A single warehouse unit fully involved.
Command from truck 29, where would you like us placed?
Water on fire.
I understand. Water on the fire, 0242.
Water coming.
Copy, water coming.
Hoover, command dispatch. For command. Be your 20-minute benchmark, 20 benchmark.
We got roof loss, minute.
Squad 3-4, rest 2-3-4. Far.
$23 far.
No, I did 2-3 hours far.
It's not squad 3-4 hours far.
Squad 3-4 hours far.
No, that's 3-4 hours far.
Acknowledge. Dispatch for command.
Command, go ahead.
Fire under control.
Fire under control, 0259.
What happened that led to the concrete slab roof collapsing and almost injuring 7 firefighters, when a structure fire in a building similar to this would stay up for far longer? There were numerous factors, and each of them contributed to how this structure's roof failed so quickly. We'll have to look inside the construction of the roof and what kind of concrete was used for this structure, including what kind of retrofit this mechanics bay was turned into without permits. The interior of the bay was changed into a nightclub, with laminated wall decorations, spirits, movable bar, refrigerator, and a cooking counter with an open range that used propane. During fire attack, the tank was located and moved out of the area. The crews moved into the structure, 2 crews on fire attack and 1 on active search. The roof slab then collapsed, mere feet away from Engine 23's crew. All of them quickly evacuated. Now let's look into why the concrete slabs failed in such a short time frame. There are several types of concrete slab used for roofing, and the one chosen for this structure is known as a hollow core slab, shown here. The 2 sections that collapsed weighed in excess of over 2,000 pounds each and fell almost 12 feet to the ground. With that kind of speed and mass, they could have easily seriously injured or killed anyone below it, as evidence from this fridge that was crushed underneath that same slab. One of the big questions to ask is, why did the Alpha Delta side collapse so quickly versus the other areas? After the investigation concluded, they found it was due to the fuel-rich heated ceiling smoke layer pushing out past the garage door and mixing with the oxygen outside. With the initial explosion seen here by the security camera, it blasted the garage door partially off, resulting in an exposed area where oxygen could be sucked in to feed the fire, creating a superheated area that was concentrated in that one part of the roof slab. The fire reached temperatures from 1100 to 1800 degrees, and this transferred heat into the concrete slabs above, pushing the embedded steel braided cables well past their critical failure temperature of 800 degrees. The slab's weight, along with the failing steel braided cables, sheared off and collapsed. Even with the firefighters cutting down the garage door to expose an opening and begin fire attack, that part of the opening had already sustained prolonged fire damage, weakening the steel braided cables within. According to what the engineering report states, The reason for structural roof collapse was the shear stress failure of the steel-braided cable located inside the concrete slabs near the bottom face of the panels. The strands are encased within the concrete and span the entire length of the concrete panel. The steel-braided cables vary in thickness, but these are the common sizes. The conductive and convective heat transfer from the concrete to the steel-braided cables was the root cause of the roof collapse. Concrete absorbs and maintains significant quantities of heat for a long period of time due to its thermal mass and aggregate properties. Hollow core concrete panels transfer heat at a greater rate compared to solid panels due to the reduced mass and internal airspace. The largest factor affecting the duration of fire resistance for these concrete panels is the amount of concrete between the steel-braided cables and the underside of the slab. The time temperature curve of a fire will also significantly influence the duration of fire resistance. Therefore, an accelerated fire, typically incendiary or arson, will likely reduce the intrinsic fire protection provided by that concrete. This is important specifically because this roof was a single-layer slab. Other roofs can look similar, but will have 2 layers and are able to support shingles or even AC units, more commonly known as dead loads, which will hold up longer under heat. The typical thought is that roofs that look like this but don't have dead loads on them would hold up longer, but that is not necessarily the case. The roof was single-layer and thin, using hollow core slabs, so the transfer of heat into it moves at an accelerated pace, combined with the concentration of heat on that one area where oxygen was feeding the flames. That means that the roof will reach structural failure even faster. Another reason for the slabs failing so quickly, found by the investigator, was that spalling was noticed over several parts of the concrete ceiling slabs. Spalling is the chipping or pitting of concrete or masonry surfaces. With less concrete on those slabs, that means less mass between the steel-braided cables and the fire and heat, so that heat can transfer even faster through the concrete and those steel-braided cables, which will reach their failure temperature faster than normal. Is spalling the cause? No, it's only another piece of the puzzle that contributed to the failure of the roof slab. So we must take into account that arriving on scene and seeing an older building made with concrete, the age can mean that it could have spalling, meaning even less time before structural failure. Additionally, if there was a gas explosion, the blast wave would contribute significantly to the weakening of the structure.
When we look at the fire plume, where the fire is actually impinging upon the ceiling, we have all that heat that's being driven up towards the ceiling. It's going into that concrete panel. Those concrete panels, it takes a while to get them heated up, but once they do get heated up, they do absorb a lot of heat and they re-radiate that heat back for a long amount of time.
We pull up and we can see the column we took the turnpike, we could see it.
So typically if they would have showed up on a regular room and contents fire that was in there that wasn't accelerated, they would have gone in there, extinguished the fire, and everybody went home, and we wouldn't be having this conversation.
I sent them to the Bureau of Forensic Sciences for analysis of accelerant detection. All of them came back hot for gasoline.
Oh, everything just happened so fast, to be honest with you. There's nothing that you can typically prepare for in regards to when that happens that quickly. And that's when we heard some things come crashing down, just merely a foot from us, right next to me.
They had no idea that there was gasoline poured in there. They didn't realize that their time had really shrunk due to the fuel that was already in the building and the fuel that was, put in there by the arsonist.
Most of the gasoline was poured inside of a storage room and also an office area.
Heat release rate does become greater. We have a more efficient fire, and so that was off of the AD corner where we did have, that ventilation happening. So when we look at why the roof actually failed at that point, that's exactly where we would expect it to fail because our fire was most efficient and our greatest heat release rate was occurring at that location because of the fuel that we had. The builders are looking to just meet the minimum building and fire codes, And in order to do that, the less product, the cheaper that stuff is, but they're still able to meet the building code.
There's a ton to take away. The way that you approach warehouses, the way you approach storage units, you don't exactly know what's above you. I was fortunate enough that Cap had some experience going into that, and I remember walking up there with the bundles. He said, do not go too far in. He wanted to make sure that we had an exit. We had means of egress, that we were, if anything was to catastrophically happen, that we were going to be able to at least make an attempt out of there.
What is the takeaway from this fire? Several factors played into this near miss for our crews. Elevated temperatures, older construction, fire flow dynamics, including the list of added fuel load inside the bays. And all of those are out of the hands of the crews involved. So it's up to us to understand how these commonly built structures perform under fire conditions. The misconception that concrete walls and roofs will hold up well under fire conditions is not necessarily true. For example, NFPA 251 rates a concrete roof with a top concrete covering for 2 hours under fire conditions. But this specific building had a concrete roof with no top covering, just tar and gravel. This drops its rating down to 1 hour.
But that's used just as a standardization to meet building code, but that doesn't mean from a fire operations standpoint that you have an hour when you go into this fire. And that really should have no bearing, and operations should not use that as any type of benchmark or any type of feeling of safety to think that they have an hour in there, because when we get these ratings, it's really just to get standardization when we're comparing different types of walls or roof coverings, that type of stuff, to say how long that they're going to last in a standard fire. Well, there isn't a standard fire. The standard fire is made up in a laboratory.
Taking a look up on the roof and not seeing AC units does not mean more time before the roof reaches a failure point. In fact, a single-layer slab roof can mean it was constructed with thinner material to merely meet the building code. Non-dead load-bearing roofs should raise a red flag for incident commanders. Now realizing that cost-saving construction was used on this structure, and the working clock and internal clock will and should be sped up on these incidents. There are numerous folks and departments that came together to help bring this to light, and we want to say thank you to them for the dedication and professionalism for this project. Stay safe, stay vigilant out there, and thanks for watching.